So in this video, let us look at a very interesting technique of polynomial division called Horner's synthetic division. So you know how to divide two polynomials. Let us take an example. So if you're asked to divide x cube minus 5x square plus 2x plus 7 by x plus 1. So how do you do this division? So the process that you usually do is x plus 1, x cube minus 5x square plus 2x plus 7. So x into x square is x cube, right? X into what is x cube? X into x square is x cube, and 1 into x square is x square. You subtract one from the other, x cube gets cancelled. So minus 5x square minus x square is minus 6x square, and you borrow one term. Now x into how much is minus 6x square? X into minus 6x is minus 6x square. So you write minus 6x square, and 1 into minus 6x is minus 6x. So you subtract one from the other. So minus 6x square and plus 6x square will get cancelled. So plus 2x minus of minus 6x is plus 6x. So you have 8x plus 7. Now x into what is 8x? 8 is 8x. 1 into 8 is 8. So if you subtract these two, you get minus 1. So when you divide this polynomial by x plus 1, the quotient is x square minus 6x plus 8, and the remainder is minus 1. And the remainder can be directly found out by putting x is equal to minus 1 in this expression. So let us check whether the remainder theorem is working. So if this polynomial is p of x, so what is p of minus 1? Minus 1 minus 5 minus 2 plus 7, which is equal to minus 1. So the remainder theorem is valid. Now this is the way in which you do the general division. So now there is an easy way to do this, and the method is called Horner's synthetic division. So now let us try to do this division using Horner's synthetic division. So there are several levels of simplifications that you can do in Horner's synthetic division. The first type of simplification that we do is by avoiding writing the coefficients of x's. For example, if you want to divide this by this, I just write the coefficients of different powers of x. 1 minus 5 2 7. This is the dividend, and the divisor is x plus 1. Here also the coefficient of x is 1 and the next coefficient is also 1. Now we just need to divide these numbers by these numbers. We used exactly the same process. So 1, this is the leading coefficient here, this is the leading coefficient here. So 1 into 1s are 1, and 1 into 1s are 1. So you subtract one from the other, ones will get cancelled. Minus 5 minus 1 is minus 6, and you borrow this 2. Next, now the leading coefficient is again 1 here, the leading coefficient is minus 6 here. So 1 times minus 6 is equal to minus 6. 1 times minus 6 again is minus 6. So you subtract again, minus 6 and plus 6 gets cancelled. So 2 plus 6 is 8, and you borrow the next number here. Again 1 8s are 8, and 1 8s are 8 again. You subtract one from the other, so 8 and minus 8 gets cancelled. 7 minus 8 is minus 1. So the whole division process is complete, and you can see that the division process is complete when the number of numbers that you have in the divisor and the number of numbers you have in the remainder becomes less than the number of numbers in the divisor. So the divisor has 2 coefficients, the remainder should have at most 1 coefficient. So now once you have these numbers, at last you can back convert these into polynomials. So this corresponds to, there are three numbers. So this corresponds to the constant term, this to the x term, this to the x square term. It is x square minus 6x plus 8. That is the quotient. And what is the remainder? You have only single term. So the remainder is a constant which is minus 1. So you can see that you get the exact same answers from the Horner's synthetic division also. And simplification being that you don't need to write different powers of x. So let us look at the next level of simplification in Horner's process. We are going to solve the same question by a further simplified process. Here, what we do is, we take the leading coefficient of divisor as it is, but we change the signs of all the remaining coefficients. So the leading coefficient 1 is written as 1, but all the remaining coefficients will have the signs changed. It is, instead of plus 1, we write minus 1 here. So what is the simplification that we get by following this process? So instead of the subtraction process, the processes convert to addition process, which are simple. So now 1 ones are 1 and minus 1 into minus 1 is minus 1. Now you don't need to bother about the first subtraction. So just at each stage start leaving one of the column and go to the next columns. So now minus 5 minus 1 is minus 6. Already we have changed the sign here. So instead of subtraction, we can do addition now. Minus 6 and 2. So 1 minus 6 are minus 6 and minus 1 into minus 6 is plus 6. So you can leave the first column. Go to the next column. 2 plus 6 is 8. Next number is 7. So 1 8s are 8 and minus 8. So leave this column. 7 minus 8 is minus 1. So if you change the coefficients, all of them except the leading coefficients, and at each stage you leave one of the column, and you can convert the subtraction process into addition process. So I hope this is very straightforward. So the quotient is again x square minus 6x plus 8 and the remainder is equal to 1. So here we are doing it stage by stage. Next you have a further simplification where you can get all the answers in a single line. So let us see that process. So the final level of simplification when you want to divide a polynomial with a linear polynomial is that we stop taking the leading coefficient. We just ignore the leading coefficient. We don't write it and just change the sign of the constant term. So if you want to divide by x plus 1, just write minus 1 here. So now, in the first stage, get this 1 here. So we'll just carry over the leading coefficient here, 1. And 1 into minus 1 is minus 1. And minus 5 minus 1, you add these two, you get minus 6 as the answer. And minus 6 into minus 1 is plus 6. And you add these two, you get 8 as the answer. 8 into minus 1 is minus 8. So 7 minus 8 is minus 1. So the last digit is the remainder and the remaining digits correspond to the quotient. Hence the quotient is x square minus 6x plus 8 and the remainder is equal to minus 1. So in this process, if you want to divide any polynomial by a linear polynomial, you can directly do it in one step if the leading coefficient is equal to 1. So let us do some more examples in the final process.